right, last time we started section 3.5. As a reminder, we're working with rational functions. Rational functions are ratios, namely fractions, where there's a polynomial on top and a polynomial on bottom. We encountered the topic of domain when we looked at it last time, in particular the denominator not being able to equal to 0. We also talked about, in general, that if the denominator in its lowest terms, like completely reduced and factored out, completely simplified, so to speak, still has a place where the denominator is equal to 0, that we get an asymptote, a vertical asymptote. One of the things that I don't know that I really said very strongly last time, and I'd like to make sure I do say very strongly, is that we actually have equations, not just numbers, right? So like the vertical asymptote here is not 2 or 4 or 3. It's x equals that specific value. It is a line. So we need to make sure that when we're writing the equation of an asymptote, we write the equation of a line. Specifically, x equals or y equals. Now, x equals are our vertical asymptotes. Horizontal asymptotes are a little bit more involved. They're not necessarily any harder. They just have different cases that come about. Vertical asymptotes, we reduce the fractions, and then we look at the denominator set it equal to 0 and solve. It's always the same process every time. But when we're working with horizontal asymptotes, we have to look at the degrees of the numerator and the degree of the denominator. So if you remember, degree of a polynomial is just the highest exponent. So if we're looking at the example we did on number 1 over here, on the example number 1, the degree on top is 0, because there's no exponents, so it's an exponent understood 0 exponent. The degree on bottom is a degree 1. Because the x has a power of 1. On number 2, the degree on top is a 2. I know I've got kind of things written on top of it. And the degree on the bottom is a 2. Okay, is everybody okay with identifying what the degree is? So based on the degree, we'll put you into one of these 3 categories. If the degree on the top is greater, category number 1, then there is no horizontal. There is no horizontal asymptote. There potentially could be what's called a slant asymptote. And if there is, I'm going to show you how to deal with that one. And so for right now, I'm just going to write C example 5. Because we're going to see we are going to see and encounter an example of that later on. But there is no horizontal asymptote. Okay, degree on top is bigger, no horizontal asymptote. If the degree on the top is smaller, that's actually our nicest scenario in terms of writing things down. If that happens, then the horizontal asymptote is y equals 0. So those 2 cases are the most easy to just work with because the degree on top gives me nothing. The degree on bottom being larger gives me y equals 0, and I'm done. Okay. The last one is the most complicated to write out. It's not hard to do still, but it's complicated to write out. The horizontal asymptote is y equals the ratio of leading coefficients. Okay, so we have actually, I'm telling you we're going to see the example 5 later on that does the first category here. We've seen an example of the second and the third category. The second category was actually example number 1. And the third category was my example number 2. So if we look back over here at examples 1 and 2, on example 1, we in fact see that the degree on top is 0. The degree on bottom, that is not good in this color screen. Let's try black. The degree on top is 0. The degree on bottom is 1. So the degree in the numerator is smaller than the degree in the denominator. So on example number 1, the horizontal asymptote, if I were looking for it here, is simply y equals 0. So over here, if we were identifying it, it's always in this category that the horizontal asymptote is y equals 0. Example number 1 did that. Example number 2, in fact, has the x squared on top and the x squared on bottom as their highest degrees, right? And the coefficients in front of them are what we care about. So the number in front of the x squareds, well, on the numerator, it's a -1, and on the denominator, it's a 1, right? So what happens is that my horizontal asymptote is y equals -1/1, or I still want to say simply again. It's just y equal -1. It's just y equal -1. That's my horizontal asymptote. So over here on example 2, my horizontal asymptote from example 2 was y equal -1. Does that make sense? It's not hard to identify the pieces. It's just kind of weird to write it out. So what we're going to do with the examples we work with after this point is that we're going to be given an equation, much like we were over here, and we're going to be asked to find several things for that equation. So on number 3, we have the equation g of x equals 1 over x squared minus 5x plus 6. And it asks us to find the asymptotes, intercepts, and sketch. So I just got through giving a test in another class, and anytime I gave directions, there was somebody who missed part of the directions. So I'm going to box all of them in just to make sure that we remember. There's 3 things we're asked to do here, and we want to make sure that we accomplish all 3 of them. So intercepts are the first ones. Asymptotes are the first ones. So there's 2 types of asymptotes. Vertical asymptotes, right, places where the denominator equals 0. Horizontal asymptotes, which have to do with the degree of things going on. So if I'm looking for this particular one, anytime I'm looking for horizontal asymptotes, vertical asymptotes, specifically vertical asymptotes, it's helpful to get things factored just to see if things reduce. Now they're not going to reduce here because it's just 1 on top, but I'm going to want the denominator factored anyway, so let's go ahead and do that at this point. So how will the denominator x squared minus 5x plus 6 factor? I'll start you out. X and x. Now what?
Minus 3 and minus 2.
Right. Minus 3 minus 2. It gives me a positive 6 at the end, negative 5x in the middle, so that's the correct one. So if I'm looking for my vertical asymptotes, what I want is I want the denominator, or the pieces of the denominator, specifically the factors, x minus 2 to equal 0, x minus 3 to equal 0, and to solve. So this one would give me x equal to 2, and this one would give me x equal to 3. So I have 2 vertical asymptotes here. Now, you don't have to do it in this order, but I find it useful to actually graph as I find pieces of information so that I make sure I put them on the graph, and I've done that part of it. So I'm going to graph as we go. So I'm doing sort of that third part, the part that says sketch the graph as we go. It says I want a vertical asymptote at x equal to 2 and 3. So I'm going to draw vertical asymptotes, which means I'm going to have a dotted line at 2 and at 3. That's what I've discovered so far. Okay, good so far? All right. Horizontal asymptotes means I look at the degree. What can you tell me about the degree of the numerator compared to the degree of the denominator?
It's less than.
It's less than. The numerator degree is less than, so which category am I in?
Y equals 0.
Yeah, the second category. So my horizontal asymptote is automatically y equals 0. So over here on the graph, it's not going to show up super strongly colored because I'm writing a dotted line on top of a solid line, but I have a dotted line right there on the y-axis. The x-axis, the line y equals 0. Okay, so I've made good progress on the graph. I have found all my asymptotes. The next box says I need to find intercepts. So my x-intercept is when y equals 0. So if y is equal to 0, it means the left-hand side is equal to 0. And the reality is, I can write it in factored form or the original form, it doesn't really matter. The reality is that the only way that this fraction equals 0 is if the top is 0. Right? I can't divide by something and get 0. That's not possible. That's not a division fact. So this doesn't happen. There's no solution to that. Namely, the numerator, because it's simply the number 1, cannot equal 0. So if I had some variables on top, I'd have something to solve. But I don't have any variables. I just have a constant. So there's no x-intercept. So that dotted line, we're actually never going to cross it. And you might be thinking, well, isn't that what asymptotes do anyway? Because we talked about it briefly last time. And it's sort of a fuzzy description to say an asymptote's a line you never cross. It's a line you don't cross on the outer edges. But sometimes you do cross asymptotes in the middle of a graph. So you could have a place where you cross a horizontal asymptote. We're not going to cross those vertical asymptotes, though. Those are definitely things we cannot touch. All right? So we're never going to touch my x-axis on this graph. The last one that I haven't done is the Y-intercept. So my Y-intercept is when x is equal to 0. That we can do, right? So I've got y equals, I don't know which version of it you want to put it in. I'll put it in the factored version just because that's the last one I've written down. If you want to put it in the original version where it's all distributed out, that's fine too. Either way, this gives me 1 on top and 6 on bottom. So my y-intercept is the x value 6, the y value 1/6. So it's crossing above the x-axis, but just barely. So in terms of a plotted point on my graph, it's like right, I don't have my actual hash marks marked. Let's do that first. We'll plot a couple of them. It's barely above the x-axis, so something like that, right? You can barely see it and plot it in there. So in order to sketch this graph, we need at least one point in each of the places where we've split it apart by our asymptotes. So vertically speaking, from the left-hand side until I get to -2, or until I get to 2, I need at least one point plotted, and I have it. It's there. I really need a point plotted between 2 and 3, and I need a point plotted after 3. 1 point's actually enough, and I'll show you why in just a second, but 1 point's what we need. So if you want to think about like what other values do I need? Well, I need a table of values. I have the value already, 0, 1/6. I need something between 2 and 3, so maybe you want to pick 2.5. I'm just going to write it in decimal form here. And then we need something bigger than 3, so maybe we pick 4. You can plug those into your calculator as you simplify or solve them. It doesn't matter to me. But if you put in 2.5, -4 is what I have written down. I don't have 4 put in, so let's put 4 in. If you put in 4, I get 0.5. So I'm just plugging them into the original equation, okay? And I want to plot them. I already plotted the point at 0, 1/6. 2.5, -4. So -4 would be down here. So I'm somewhere like right here, right? 2.5, -4. And then 4.5. So here's 4. And then I want something halfway between 0 and 1, so about right there. I know it kind of looks like it's the same height as my 1/6 because I just don't have enough accuracy to be able to plot very well. But I have what I said I needed, right? 3 points, 1 in each of those sections. So the whole point of asymptotes is they tell us a lot about how the graph is behaving. If I go from the y-intercept and I move to the left-hand side, it has to get close to the asymptote, so it has to look like that. And if I move in the direction of the asymptote, so toward the right, this point has to get close to this point and has to be approaching. See, it can't go down because then it would cross the x-axis, right? Like that's not an option. So it must have to go up. So my graph ends up looking like this. On the lower part, it's trapped between these two asymptotes, can't cross them. And it can't go upwards because then it would cross the x-axis. We don't know how many x-intercepts, right? So it must mean that it's opening downward. So in a very real sense, although I didn't draw my lines out very far, I'll draw them further, it kind of looks like a sandwiched parabola. I meant to do that in yellow, but... So it's sort of sandwiched, squished in between there. Again, because that's the only options I have. I have to get close to the asymptotes. Can't cross them. This is what happens when we try to get close. This point right here, over here at 4 1/2, is going to look much like my point over here mirrored over. So if I move towards the right-hand side, it has to decrease down to the x-axis. If I move toward the left, it increases towards my asymptote at x = 3. And remember, just like we were doing in section 3.4, I believe it was, this is a sketch, right? It's not perfect, but the overall basic image that we're looking at should look kind of like this. If you're using a graphing calculator or you're using the computer to graph this to just check yourself to see, like, does my sketch sort of seem reasonable, which I advise you to do if you have the ability to do so, be sort of forewarned that depending on how old your technology is, so I'm thinking more like the graphing calculator technology, what it might do is it might try to connect the edges of those sort of swooping, arches, and it might actually end up making it look kind of like this, where it attaches them together. It's not attached together, don't be misled, but your calculator sometimes doesn't know quite what to do with asymptotes, and it will try to connect the dots when it's not appropriate to do so. So it is possible your calculator might look like something that's not quite right. But aside from that, the graphs tend to look pretty good. Sometimes you have to expand your windows in order to see all the pieces too. That's another thing that can happen. Okay, we're going to do another example. This one's a little bit simpler because the denominator doesn't have, two components to it. It just has one. If I were to try to factor this on the top, I could certainly try to do that, but the best I can do is to pull out a 2, leaving me with x plus 2, which is not the x minus 1 on the bottom. So it doesn't really affect anything in terms of reducing the fraction. We want to check that, and it doesn't do anything here. All right, so vertical asymptotes is where we'll start first. How do I find vertical asymptotes? Yeah, I set my denominator. In this case, it's x minus 1 equal to 0, and I solve. So my vertical asymptote, it's not 1, it's x equals 1. And so over here where I'm graphing it, I'm going to go ahead and put in a vertical asymptote at x equal 1. So 1, 2, 3. I'll just mark 3 of them out. We'll add more if we need more later. And you want to make them, kind of equal as best you can sort of visualize them to be so. So x equal 1, I'll draw mine in a different color just to differentiate visually for us talking about here. It would look like that. Okay, so far so good? Excellent. All right, now we're going to move on to horizontal asymptotes. What can you tell me about the degree on top compared to the degree on bottom? They're the same. They both have x to the power 1, right? So that means we're in this third case where we look at the coefficients that are in front of the numbers attached to them. So this will be y equals, what's the leading coefficient on top and on bottom? Okay, so I have 2 over 1, or just simply y equal 2. So this one's not on an axis. It's actually a separate line. So this is y equal to 2. It's going to be something like that. All right, I'll shift it a second here. That does not look straight at all. That's better. Okay, so let me just tell you, there's only 4 choices of what can happen here. Can I draw all 4 of them without you sketching anything for a moment? Okay, here are your 4 choices. I could have the graph do this. This is one option. Or it could be upside down doing that. Whoa. Okay, kept going. Like that. That's option number 2. Or I could have one branch on top and one branch on bottom like this. Or I could have one branch on bottom over here and one branch on top over here like this. These are the only 4 options because I only have 4 different sort of regions of my graph that have been pieced together here. Does that make sense? Okay, so I need to figure out where my graph is located by some points. I need to do one more thing before I get there. I want to look at the intercepts because it specifically asks me to find them. That will give me at least one of my ordered pair points that I need. And then if I don't have enough after that, I might have to plot some additional points like I did over here with that number line t-chart over here at the end. So let's take a look at X-intercepts and Y-intercepts. I usually go in order, doesn't really matter. Your X-intercept is where y is equal to 0. So this would be 0, and it's 2x plus 4 over x minus 1. Now I mentioned on the last problem, it's where my numerator is equal to 0. In a very real sense, you can think about that because if I were trying to solve this, I would potentially try to cross multiply. or I would multiply by the denominator, and that x minus 1 gets canceled out by multiplying by 0. So from an algebraic experience or perspective, we also can see that my numerator set equal to 0 gives me locations where y is equal to 0. So I will subtract my 4. So negative 4 is equal to 2x, divide by 2. And what is the x value I end up getting? Negative 2. So my x-intercept is an x value of negative 2 and a y value of 0. Please make sure, just like when we talked about asymptotes, their equations, they need to say x equal or y equal. When we're talking about intercepts, they are points, which means they need an x-coordinate and a y-coordinate written in parentheses. That is how points are written. So on my graph, I can plot that now. Negative 2, 0. It's right here. So I know what the actual part of the graph in that area has to look like. It has to be in the lower left quadrant, not in the upper left quadrant, right? I mean, like I have a point down there, so I've got to have the whole graph down there now. So if you wanted, you could actually finish out the sketch in the bottom part. It has to look like this. Now, I'm going to erase it just a second. Notice it's going to cross the y-axis as well. Do you guys see that? Just how I drew it. I'd like to be able to at least plot the y-axis intercept correctly, so I'm going to pause on that part for just a second. We'll get our y-intercept, and then we'll actually graph that part. So these were asymptotes, x-intercept. Now I have my y-intercept. And my y-intercept is when x is equal to 0. So y equals, and I have 2 times 0 plus 4 over 0 minus 1. And what will that give me? Yep, negative 4. So my y-intercept is 0 for x, negative 4 for y. So over here, I actually need to cross the y-axis. I need one more of them here at negative 4. So I'll continue to connect my dots down like that through that intercept. So I have narrowed down the options. At this point, it's either possible that the graph goes up here or down here. Don't have an option, or do I? I contend that it can't be where it's currently drawn. Any idea why? I know that for sure. That point is crossing the x-axis. It's an x-intercept, right? Do we have another x-intercept? We don't. So I know, that generally speaking, that my graph has to be up here somewhere. I just need to plot one point, and I'll have it up there. But it will definitely be in the top right, not on the bottom right. So we pick any value we want. 2 is as good as any, so I'm going to pick 2. So if x is equal to 2, what is y? So if we plug 2 in, I have 2 times 2 is 4, plus 4 is 8 on top, divided by 1 on bottom. So I think it's at 8. Does that look right? It's not especially nice because my graph doesn't go that high. So let me extend my graph a little bit, but I'm at 3, 4, 5, 6, 7, 8, thereabouts-ish. And plot right there. Oops. Right there, lining up right. And again, it will swoop down. We will extend our vertical asymptote up, and it will continue on up through that particular point towards the asymptote. Any questions on that? Okay, so I already promised you something special is going to happen on number 5. Do you remember what I promised you is going to happen? What was it called? A slant asymptote. You might also have heard them referred to as an oblique asymptote before. They're just words that are used interchangeably. So we'll start by finding our vertical asymptote and our horizontal situation. Like we'll list those out first. What's my vertical asymptote here? Yes, so David didn't want to talk, but he's showing me, right? Yeah? X equals 0. Right? Denominator equals 0, so it's just x equals 0. So on my graph over here, as I'm sort of starting to plot that, whoops, that thick, we have the line at x equals 0. Where's the line at x equals 0? It's the y-axis, you bet. So we're not going to actually have a y-intercept here because I actually have an asymptote on the y-axis at this one. All right, so keep that in mind when we get to that part of it. We will not have a y-intercept. What can you tell me about horizontal asymptotes? What can you tell me about the degree of the numerator compared to the degree of the denominator? It's bigger on top, right? So it's actually in the first category. The degree on top is bigger, which means there's no horizontal asymptote. But when there is none, we stand a chance of having a slant asymptote. So how do we know? Well, a slant asymptote will happen when the degree on top is exactly 1 bigger. And this one is, right? The degree on top is exactly 1 bigger. So how do we find the slant asymptote? Well, you may not like my answer, but the answer is that we do long division. Here's the way long division works with polynomials. The numerator goes underneath the division bar, and I would encourage you to, generally speaking, write out all the pieces like we would if we were doing synthetic division. Okay, oops, that's supposed to be a -1. So just in case you need it. You may not need it. In fact, I don't think we need it on this one, but you might. So we leave a space holder for that. And you're dividing by your denominator. Now, usually the denominator is more than just x. It might be x minus 1 or something like that. But you divide by whatever the denominator is. This is similar to doing synthetic division, except we have the variables present in the division instead. So we ask ourselves, how many times does x go into x squared? And we would say it goes in twice. Well, to x times anyway, right? X times x would give me x squared. So if I were to then multiply, if you think about multiplying this down, x times x gives me, in fact, x squared. Like that, and I subtract. Nothing comes out of that, right? That is to say, these cancel completely, which is the goal. I don't end up having to do anything with the 0x. Typically, I would bring the next parts down. I would say, okay, 0x minus 1. Well, I don't need to multiply the x by anything to get 0x. It's not there. Again, usually it has more to it. The division is a little bit more involved. So we would end up getting plus 0 here. Normally there's another number. So this would be 0x. And then we have -1. At the point when the remainder is less in degree than the divisor, right? So it's a 1 compared to an x, or it's an x compared to an x squared, or it's an x squared compared to an x cubed, right? At the point when that happens, we stop. And this up on top with y equals is the equation of the asymptote. So ours is our slant asymptote's equation is y equal x. So it'll always be a linear equation. Okay, so it'll always say something like y equal x, y equal 2x plus 3, y equal 3x minus 7. It'll always be a line that comes out of this. And we're going to graph it. So the line y equal x, as you know, looks like that, right? Y-intercept of 0, slope of 1, so we go up 1 and we go right 1. This is my slant asymptote line. Okay, so this is different looking because it's at an angle. So here's what I want you to recognize, the different pieces of where parts of this graph might lie. There is a region right here that I could have a part of my graph lie in, and it would be sort of sandwiched in there to look kind of like, you know, a V on its side. And I have that same piece showing up potentially down here. So I might have a graph that has one of those two pieces, or maybe both of them. On the outer edges, I have this sort of like expanded or wider piece that I would have had. So normally I would have had like that, right? Now I have a piece that looks potentially like this, or like this. So these are the 4 locations. It can't be in all 4. But it's going to be in 2 of those 4 places. So we need to figure out, whoops, I didn't mean to do that. I meant to do this. Which of those 4 pieces we actually have. And we haven't found our intercepts yet, so we'll do intercepts next to see if that will help us at least for one of the pieces. So my x-intercept still stands a chance at happening. My x-intercept is when y is equal to 0. So 0 equals x squared minus 1 over x. My numerator could equal 0, right? It sure could. If I cross multiply by my x, right, there's this understood 1 here, I would get that x squared minus 1 is equal to 0. You can either factor this. It factors lovely as a difference of squares, x minus 1, x plus 1. That's an option. Or because I only have one location where x is, right? I have x squared, but it's only in there one place. It's not an x squared and an x. If you wish, you could add this to the other side and then square root. So x squared equal 1, and then we take the square root. What is the square root of 1? I need the plus or minus because I put the square root on and a 1. It's actually very helpful. The x values are 1 and -1. The y values are 0. So I actually get 2 x-intercepts that I get to plot out of this, not just 1. So x equal -1 puts me, about right here. And x equal +1 puts me about right here. And that's actually on either side of some asymptotes. So it tells me exactly how it has to be plotted at this point. I have enough data to do that because it's on either side of that x, or the vertical asymptote, the line x equals 0. So the graph on the left-hand side has to look like this. The graph on the right-hand side would have to look like this in order to contain those two particular points. Now, I didn't write it down, and I still probably should, even though I've graphed it at this point, because it asks me for intercepts. The y-intercept is letting x equal 0, and there is none on this one. If I tried, I would get 0 squared minus 1 over 0. I can't divide by 0. That's not allowed, right? So I would have none. So there is no y-intercept from an algebraic perspective either. Any questions on that? There's one more piece of information in this section we're going to do a couple of examples on, not directly related to graphs. Okay, so let's take a look. What's going on in these problems that's different than the ones before? It's an inequality. The directions actually talked about, or the title of this section talked about looking at graphs and inequalities. So this is the inequalities section. The inequalities actually are very, very friendly. They work exactly like the inequalities with polynomials. Exactly. That's very nice for us. So what I'd like to remind you of what is generally speaking what we did with polynomials, and you did it in 3.4. When we had inequalities with polynomials, we factored everything out. We set all the points equal to 0, and we put them on a number line. And then we tested points in the individual pieces of the number line. That was one way. The other option that we did is that we did the same sort of thing, but then we looked at an actual graph of the function to decide where it was above the x-axis or below the x-axis. We're going to work with the test point method here, and the reason that we are in particular is because graphing is harder than test points. There's more involved. If you already had a graph of this, that would be great. If you don't have a graph of this, actually creating the graph to do that particular part of the problem is not the easiest way to do the problem. Okay? It may be the most visual way to do the problem, or the most intuitive way to say, oh, I know why this works, but it's not the quickest way to do it. So what we're going to do, like we did in the last section, is that we're going to factor everything completely. Factor the top, factor the bottom. That's our first steps. So on the top, it's already in factored form. How does the bottom factor? Yeah, we saw it just a minute ago. We had the similar part of the problem. X plus 1 and x minus 1. Okay, everybody good? So we have it all in factored form. It's lovely. We have 3 factors. Agreed? If some of them have to repeat, you don't have to list them all separately. That's fine. But these are all distinctly different. And I'm going to set all of them equal to 0. Now, I recognize I cannot have all of them actually equal to 0. I can't have my denominator equal to 0. I know that. But I'm just getting test points or interval points on a number line. I'm not actually setting things equal to 0 from the actual inequality. I'm just finding those interval points. So the first one, x plus 3 equals 0. What does x equal? -3. I shouldn't bracket it in. We're not giving answers. We're just using these. How about the second one? X plus 1 equals 0. -1. And the third one? +1. These 3 points now will go on a number line. They need to go in order, otherwise you're going to find yourself in a confusing mess. So please make sure you're paying attention to the numbers you're putting in there. -3 is the smallest one I have. -1 comes next, and then 1. And I'm not trying to space things out evenly. This is not a graph. This is really just a number line that I'm using to test some points. That's all I'm doing. Okay, is everybody good with that? Oh, I'm sorry. Yes, thank you. It should be a 1, not a 3. Zooming in and zooming out. Thank you. Okay, is that better now? And we're good? Lovely. There are 4 different parts of this number line. So this is kind of like looking at the 4 different parts or the 3 different parts or the 6 different parts on a graph, right? I'm just looking at the different sort of areas of the space that I'm working with. There are 4 spaces here. Agreed? And we're going to test a point in each of those 4 spaces. The point that I test and the point that Kylie tests and the point that David tests and the point that Tori tests, they don't have to be the same. It doesn't matter. You just have to test a point in that area. So I tend to test points that are whole number values. I think it works a little bit easier. I'm going to test, whoops, get a different color. I'm going to test -4 over here. -2 is good between those. I always like to test 0, and I'm going to test +2. And I want to plug each of those values into the original equation. If you want to put it in the factored form of it, that would be okay as well. It wouldn't hurt anything. But I'm wanting to know if I put them into this, do I get positives or negatives? I don't really care about what sign I get. I care if they're positive or negative. I know that for the purposes of using just arithmetic or using your calculator, like a scientific calculator, this is very straightforward. There's a really cool feature, and I think I've shown it to you before, but I'd like to mention it one more time here because it's so nice in your calculator if you're using a graphing calculator like a TI. So let me show you what you can do if you're using a TI. Okay, so if we're using this one, I'm going to put my equation into y equals. So I just hit y equals. The entire numerator needs to be in parentheses. That's x plus 3. Divided by, and the entire denominator needs to be in parentheses. That's x squared minus 1. Is that okay? All right, so I believe that you have all set up before that your table allows input values. You can check that by hitting second and graph, and you should have a table that you're able to delete x values from. Okay? If you don't have the table set up that way, there's a table set button right here above window, and you hit second table set. It needs to say ask on the top line and auto on the second one. Once you have it set up like that, you can just enter those values, and I had 4 of them, -4, -2, 0, and 2. And it does all the data entry for you. That's a very nice feature. Again, it's not because you can't do it any other way. It just works really fast and easy, so it's very friendly. What you see happening here then is that at -4, I got a negative. At -2, I have a positive. Whoops. At 0, I have a negative. And at 2, I have a positive. We'll come back to this screen in a second. So these are the signs, negative, positive, that I've gotten out of entering those data values into the equation. Which ones do I want? Do I want the negatives or do I want the positives? Positives. How do you know, Levi? Right. So the inequality we are working with tells us which one we want. This one says greater than 0. That's positive. So in terms of the pieces on the graph, it's this piece and this piece. So far, so good? I need to write the answer, but I need to be careful about whether to include parentheses or brackets. Now, if this had just said greater than 0, they'd all be parentheses, and that'd be simple enough. Right? They'd all be parentheses. Parentheses on the infinities, parentheses on the numbers, no big deal. Because there's an equal to, I have to pay more attention. I don't just get to put brackets everywhere either. I get to put brackets in some locations and not in others. So for example, x equal -3 would really make this thing equal to 0, right? So I can actually put a bracket on the -3 value, and it has to open in the direction of the shading, so it would look like this. But if I have x equal to -1 or x equal to +1, my denominator will equal 0. And I can't have my denominator equal to 0, right? I can't divide by 0. So even though it has an equal sign, -1 and +1 don't actually make this equal to 0. They make it equal to being undefined. So I actually have, if I were graphing it, I would have asymptotes there. For the purposes of our question here and answering it, I'll have parentheses to represent that I can't equal those values. And then transposing that number line kind of a graph into an answer type form, my answer then is that my -3, my interval goes from -3 to -1, bracket on the 3, parenthesis on the 1, union 1 to infinity. And that's my solution. So we're going to do the same thing again on the next problem, but of course there's a variation. Any questions on this one before I flip my screen? Okay, let's take a look. If x plus 1 over x minus 2 is greater than 3. How is this different than the previous problem? This is not 0 over here, is it? That is a problem. We must have 0. There is no room for compromise. It will not work if 0 is not over there. Absolutely will not work. So the first thing we need to do is we need to boot the 3 to the other side so that then I'll have a 3 moved and I'll have a 0. So the first thing to do is to move my 3. So now I have, now I have x minus 1, plus 1, over x minus 2 minus 3. It's greater than 0. So I've eliminated the issue before that I had, which was where I did not have a 0 on the right-hand side. But this is still not quite what this one looked like over here, right? Now what's going on? Well, I don't have a single fraction, right? I need a single fraction for this to work as well. So how am I going to combine these so that I have a single fraction instead of a fraction in a whole number piece? I need to get a common denominator. So yes, I need this to have a -3 above. I need the denominator to be an x minus 2. But it has to be equal to what I started with, which means if I multiply the denominator by x minus 2, I have to do it to the numerator as well. Does that make sense? Right, I'm combining pieces. One was a whole number piece, one was a fractional piece. I got to get the same denominator. So we're going to see what we have here. Let's see, I've got x plus 1 still. I'm going to distribute the -3 through, so I have -3x and positive 6, still over x minus 2. If I combine like terms, what do I have on top? I'll start you out, -2x, then what? Plus 7, thank you, Tiffany, over x minus 2. Okay, it actually looks like this one started now. It's actually simpler than this one started because I don't have factoring to do in the denominator. So there's nothing to factor because I don't have x squareds anywhere, right? I mean, like that's really the gist of that. These are linear terms on top, linear term on bottom. Is everybody okay at this point? Okay, so what I did after I got this in factored form, which was the step right here, is I set each of the pieces, and in this case I just have two pieces, one on the top and one on the bottom, equal to 0. So I have -2x plus 7 equals 0, and I have x minus 2 equals 0. The first one requires a little more solving. I have -2x equals -7, and if I divide by -2, what does x equal? 7/2, or if it bothers you to write it that way, you're welcome to use the decimal form. It's 3.5. That's fine as well. How about the other one? What does x equal? 2. So these are the 2 values this time instead of 3 that I will put on my number line. Making sure, of course, that I put them in order. 2 comes first. I think I'll use the decimal form this time. 3.5 comes second. And we need points in and around these points. So what's a nice number before 2? 1, or my favorite, 0. So use your 1 or use your 0. How about between 2 and 3.5? 3 is good. And then after 3.5, maybe you pick 4 or something a little bit bigger. I'm going to go back to the calculator and put those values in. So let me put that screen on. We can put in our original equation, but we need to put in the equation where everything's shifted to the other side at the very least. So if we do that, or you can put in the reduced form one, it doesn't really matter. So if I put in the original one, I have x plus 1 over x minus 2, like that, and then I had minus 3. Or you can put in parentheses on top, negative 2x plus 7 over x minus 2. And I go into my table, and I'm going to put in 0, 3, and 4. Oh my goodness, y'all, that's how many this is not showing up right. I'm sorry. I had it. There we go. 0, 3, and 4. This is what I put in my calculator for y equals. So it's negative, positive, negative, right? Okay. So I have negative, positive, negative. Which do I want? Positives or negatives? Positives. How do I know? Yeah, because it says greater than 0, right? It says greater than 3, and then it said greater than 0 all the way down. So it's greater than 0. I want the positives. That's the part that's sandwiched in between. And it's actually very friendly that it does not have greater than or equal to 0. Because it doesn't have the equals, it means everything's got parentheses. I don't have to check and be sure about any of it. I know I've got parentheses. So it's the sandwiched in between part. Let me shift this up. And my solution would be from 2 to 3.5, or 7/2, if you want to write it that way. That's not an ordered pair. That is a solution set with an interval on this one. Any questions on that one? All right.